Dear students, let's take few elementary properties of complex line integrals. First property is integration of integral over C fz plus gz dz is integral over C fz dz plus integral over C gz dz. Second property, integral over C fz dz is minus times integral over minus C fz dz, where minus C is the opposite arc of the contour C. Means if contour C is from A to B, then contour minus C is from B to A. Third property, integral over C1 plus C2 fz dz is integral over C1 fz dz plus integral over C2 fz dz, where end point of C1 coincides with the initial point of C2. Property 4 is integral over C k fz dz is equal to k times integral over C fz dz. Fifth property, integral over C k1 f1z plus k2 f2z and so on plus kn fnz dz is equal to k1 times integral over C f1z dz plus k2 times integral over C f2z dz and so on plus kn times integral over C fnz dz, where k1, k2, kn are complex constants. And property 6 is modulus of integral over C fz dz is less than or equal to integral over C modulus of fz into modulus of dz. This is very important property and we shall be using it while proving certain theorems. Okay, let's take few examples. Evaluate integral over C dz upon z minus a, where C represents the circle mod of z minus a is equal to r. Now, because equation of the circle is mod z minus a is equal to r, which is center is at the point A and radius is r. So, mod of z minus a is equal to r. This implies that z minus a is equal to r into e to the power I theta. Theta varies from 0 to 2 pi. So, therefore, dz is equal to I times r e to the power I theta d theta. So, therefore, integral over C dz upon z minus a is equal to integral 0 to 2 pi. In place of dz, we write I r e to the power I theta d theta, and in place of z minus a, we put r e to the power I theta. R e to the power I theta gets cancelled. So, this is I times 0 to 2 pi d theta, which is 2 pi into I. So, this is value of integral over C dz upon z minus a. Okay, let's take next example. Evaluate integral over C z bar dz, where z is equal to 0 to z is equal to 4 plus 2i along the curve C defined by z is equal to t square plus it. This is the first part. Now, what is 0? Z is equal to 0. Z is equal to 0 represents the point 0, 0. And z is equal to 4 plus 2i represents the point 4, 2. And the curve is given by, first z is t square plus it, say this is x plus iy, then x is equal to t square and y is equal to t, that means x is equal to y square, that is y square is equal to x. And what does this represent? This represents a parabola like this. So, 0, 0 is a point and 4, 2 is a point on this parabola. Now, when z is equal to 0, that means t square plus it is 0, 0 plus I into 0. So, therefore, t is equal to 0. That means origin corresponds to t is equal to 0. And similarly, when z is equal to 4 plus 2i, that means t square plus it is 4 plus 2i, that means t square is 4, t is equal to 2. So, therefore, t is equal to 2 is a value which satisfies both the equations. So, therefore, t is equal to 0 to t is equal to 2. T varies from 0 to 2. And because z is equal to t square plus it, so differentiating with respect to t, we get dz is equal to 2t plus I times dt. And z bar is t square minus it. Now we have to integrate integral over C z bar dz. Okay, put the values. So therefore integral over C z bar dz is equal to, convert into terms of t. T varies from 0 to 2. In place of z bar, write t square minus it. In place of dz, write 2t plus I into dt. So multiply it. So we have 0 to t 2t cube plus t minus it square into dt, which is 2t raised to the power 4 upon 4 plus t square upon 2 minus it cube upon 3, limits 0 to 2. And if you put the limits, the answer will be 10 minus 8 upon 3 into I. Now in the second part, we have to integrate the same function, integral over c z bar dz, from 0 to z is equal to 4 plus 2i. Now in this case, the curve is the line from 0 to z is equal to 2i, and then from z is equal to 2i to z is equal to 4 plus 2i. Now z is equal to 0, as you have seen, represents the origin, right? Z is equal to 2i is this point 0, 2, and z is equal to 4 plus 2i represent the point B 4, 2. So we have to go from O to A and then from A to B. Okay, let's do this. Now along OA, x is 0. So therefore z is equal to x plus iy is equal to I into y. So dz is I times dy, and z bar is minus iy. So therefore integral along OA z bar dz is 0 to 2, y varies from 0 to 2. In place of z bar we write minus iy. In place of dz we write I into dy. So integrate minus I into plus I is minus I square, which is plus 1, and integral of y is y square upon 2, limit 0 to 2, which is equal to 2. And now let's go along AB. Along AB, y coordinates is constant, which is equal to 2. So therefore z is equal to x plus iy, which is equal to x plus 2i. That means dz is equal to dx, and z bar is x minus 2i. So therefore along AB, z bar dz is 0 to 4, because in this case x coordinate varies from 0 to 4, and z bar is x minus 2i, and dz is equal to dx. So integrate this. So integral of x is x square upon 2 minus 2i x, limit 0 to 4, which is equal to 8 minus 8i. So therefore over the whole contour, integral over c z bar dz is equal to integral over OA z bar dz plus integral over AB z bar dz. So put the values. This is equal to 2 and this is equal to 8 minus 8i. So therefore answer is 10 minus 8i. Now you can see here that points, see this is from 0 0, we are going from 0 0 to 4 2 in this case, and also in the previous case when we move along the parabola. But answer in this case is 10 minus 8 upon 3i, and answer in the second case is 10 minus 8i. So answers are different. Why so? The reason is that z bar, the function which we are integrating, z bar dz, z bar is not analytic because it is not differentiable. So function has to be differentiable, means analytic, then only values of the integral along any path will be same. Okay, let's take third example. Evaluate the integral I is equal to integral mod z, or mod z is equal to r real part of z dz on the circle. Now let's suppose that z is equal to x plus iy, then z bar is x minus iy. So if we add these two equations, we have x is equal to z plus z bar upon 2. Now what is x? X is real part of z. So real part of z is z plus z bar upon 2. We have to integrate this over the circle. So therefore let's convert into terms of r and theta. So on mod z is equal to r, we have z is equal to r e to the power I theta. So dz is I r e to the power I theta d theta, and z bar is r e to the power minus I theta. So therefore a real part of z is r e to the power I theta plus r e to the power minus I theta upon 2. So therefore I is equal to integral over mod z is equal to r, real part of z dz is integral 0 to 2 pi, real part of z is r e to the power I theta plus r e to the power minus I theta upon 2. In place of dz, we write I r e to the power I theta d theta, which can be written as I r square upon 2 integral 0 to 2 pi e to the power 2 I theta plus 1 d theta. E to the power 2 I theta can be written as cos 2 theta plus I sin 2 theta and plus 1 d theta, which is equal to I r square upon 2. Integral of cos 2 theta is sin 2 theta upon 2. Integral of sin 2 theta is minus cos 2 theta upon 2. Integral of 1 is theta. Limits from 0 to 2 pi. So put the limits. So we get the answer as I into pi r square. Okay, let's take one more example. Evaluate integral over c mod of z dz, where c is a straight line from z is equal to minus I to z is equal to I. Z is equal to minus I represents the point 0, minus 1, because z is x plus iy, then x is 0 and y is minus 1. Similarly, z is equal to I represents the point 0, 1. So we have to go from A to B. So the curve is from A to B, where A is the point 0, minus 1 and B is the point 0, 1. Now because this is x-axis, so along AB x is equal, this is y-axis, so therefore along AB x is equal to 0. So therefore z is equal to x plus iy, and because x is 0, so therefore z is equal to iy, so dz is equal to I times dy. And mod of z is equal to mod of iy, which is equal to modulus of y, because modulus of I is equal to 1. And by definition, mod of y is equal to y if y is greater than or equal to 0, and minus y when y is less than 0. Okay, now let's come to our original problem. Integral over c mod of z dz, which is equal to integral minus 1 to plus 1. Mod of z is mod of y, and dz is I times dy. Now break into two parts, minus 1 to 0 and 0 to 1. When y is negative, because minus 1 to 0 y is negative, so in that case mod of y is minus y. And when y is positive, so therefore from 0 to 1 mod of y is equal to y. So now integrate it. Integral of this will be minus y square upon 2. Integration of this is y square upon 2. Take 1 by 2 common, so this is I upon 2. Minus of y square, limits minus 1 to 0 plus y square 0 to 1, and put the limits, we get answer as I. Okay, let's take last example, fifth problem. Evaluate integral over c mod of z dz, where c is the left of the unit circle from z is equal to minus I to z is equal to I. Now, unit circle means center is at the point 0, 0, radius is 1, and we have to take left of the unit circle in this portion, and we are moving from z is equal to minus I to z is equal to plus I. Now, at this point, what is the angle? This is 270 degrees, so therefore theta is 3 pi by 2, and at this point theta is pi by 2. So mod z is equal to 1 means z is equal to e to the power I theta, so dz is equal to I e to the power I theta d theta. So therefore integral over c mod z dz is equal to integration 3 pi by 2 to pi by 2. These are the limits for theta. Mod of z is 1. It's given to us because it is a unit circle, and dz is I e to the power I theta into d theta. So integrate it. Integral of e to the power I theta is e to the power I theta upon I. Put the limits. We have e to the power pi I by 2 minus e to the power 3 pi I by 2 I minus minus I, which is equal to 2I. Okay. Thank you so much.